So we are given two equations. The first one is f of x is equal to negative half times x plus 5 squared minus 3, and g of x is equal to plus or minus the square root of negative 2 times x plus 3 minus 5. So we are asked to determine if they are inverses, and there are three methods we are going to do this with. So the first method, as I have set up over here, is replacing the x and y values with each other. So I started off with the first equation, f of x is equal to negative half of x plus 5 squared minus 3. So I switched out the x for the y value because f of x is the same as the y value. And then I rewrote the equation as that. Then I got rid of the minus 3 by adding 3 to both sides over here. And then I went on to delete this negative 1/2, and by multiplying it by negative 2 on both sides, and then it became negative 2 times x plus 3 is equal to y plus 5 squared. And then I squared both sides so that I can, or square rooted both sides so I can get rid of the squared. So we are left with negative 2 times x plus 3, the square root of negative 2 times x plus 3 is equal to y plus 5. I subtracted y minus 5 from both sides, and I was left with the equation the square root of negative 2 times x plus 3 minus 5 is equal to y. And that is the exact same equation as g of x if we look at that. So that's a big yes to as whether they are inverses or not. That's a very big help. And I did this exact same thing with g of x just to make sure. And I ended up getting that negative 1/2 times x plus 5 squared minus 3 is equal to y, which is the exact same thing as f of x. So we have determined that they are both inverses using this method. Alright, so now we are going to determine whether these are inverses by using function composition. So to do that, we are basically doing the equation f of x. We're replacing g of x with x in f of x. So the equation, or the y value, becomes f of g of x. And then everywhere I see x in f of x, I replace with the entirety of g of x. So it became this right here, negative 2 times negative 1. This is where the x was placed. It becomes negative 1/2 times x plus 5 squared plus minus 3. And then plus 3. That plus 3 came from the f of x because we have finished with g of x. And so then I proceeded to get rid of terms that cancel out each other in here, like this minus 3 and plus 3. They got rid of each other. This negative 2 and negative 1/2 canceled each other. And this squared canceled the square root. And we are left with x plus 5 minus 5, which cancels the 5's out. And so we are left with f of g of x is equal to x. And that is exactly what we are looking for when we do function composition. We want the final answer to be x. And that's how we can prove that these are inverses. So using that same paper, I'm now going to do our third and fourth method, which is, well, graphing this equation. And then after graphing it, we are going to determine if they are inverses using ordered pairs. So I graphed this equation by starting off with the equation f of x is equal to negative 1/2 x plus 5 squared minus 3. We already know the a value, which is negative 1/2. It's a downwards parabola because it's an even function, and it's going to be negative 1/2, so that makes it an opening down parabola. We have a c value of x plus 5, which will make it x minus 5 actually. So it shifts left 5, and it's going to shift down 3. So I plotted that down right over here. So we know that the first point is going to be negative 5 comma negative 3. And that is this point right over here. And so, yeah, and then I opened it down as a parabola right from that spot onwards. In g of x, we have negative 2, the square root of negative 2 times x plus 3 minus 5. We know that c value again is x plus 3, so it's going to be negative 3, shifting left 3. And we have d value of negative 5. It's going to be shifting down 5. We have negative 2 as our a value. So it is going to be negative odd function. So it's going to be going downwards. That's an end behavior we will see. And then we have the point of we have the point of negative 3 comma negative 5. And if you notice that this point over here, -3, -5, is just -5, -3 switched. So we can determine that these 2 points are what make these two functions inverses, because there are the x and y values of each switched. Alright, so now let's look at this equation. And the first thing we're going to do is describe this transformation happening in this equation. So we can see that we have an a value of -2, and that means that this equation is being vertically compressed, vertically stretched by a factor of 2. And since it's also a negative number, it's being reflected across the x-axis. And then we have the plus 15 on the x, so that's going to be shifting left 15. And then minus 10, that's a d value, so it's going to be shifting down by 10. So since we ran out of memory on that first run, this will have to be part 2. So we have already described the transformation of the given equation f of x. Let's focus in on there. F of x is equal to -2 cube root x plus 15 minus 10. And now we are going to determine the x and y intercepts using the filling in 0 for the x and y as needed to find each intercept. And by doing that, we got all the way down here to our x-intercept was equal to -140, right over there. And then over here, we found our y-intercept, again by filling in 0 for the x, and we got that the y-intercept was -15. Here is a more complex equation that I did. If the first one wasn't enough, and as you can see we still got 140, -140 is equal to the x-intercept. Now, using the information that we have, the x and y-intercepts, we can plot those 2 points. Over there, the x-intercept of -140 and the y-intercept of -15, and then use the equation itself that we got. We know to be an odd function, so we know the basic shape of it, and we also know that it is a negative odd function, so we know the end behaviors. So we can sketch a quick or make a quick sketch across those 2 points using the basic shape of an odd function. And now that we've found the x and y intercepts and all that, we can now determine the domain and range. And since we don't have any holes or asymptotes or anything that's going to prevent it from being any extraordinarily or unnatural domain or range, we know that this is going to be, for the domain, it's going to be -infinity, positive infinity in parentheses. And for the range, it's going to be the exact same of parentheses, -infinity, positive infinity, parentheses. And that's part 2 done. Now we are given a new equation and we're asked to solve for it. So this is exponent properties. The equation is x to the 1/2 times y to the -2 over x to the -7/4 times y, all of that to the 4th power. Well, sorry about that. Again, my memory ran out. This is probably one of the hardest thing I've ever done, harder than an actual retest. But, so we were at question number 3, which gave us an equation and asked us to use exponent properties to simplify. So that's exactly what I did over here. I used all these exponent properties and got down to the final answer of x to the 9th over y to the 12th. But that was in rational form, and so I multiplied both sides by 1/3 to simplify their their exponents to x over x to the third power over y to the fourth power, which give us the final answer of x third times y, which gives the final answer of x third divided by y to the fourth. And the exponent properties we used in this were product of powers, quotient of powers, power to a power, and negative exponent in numerator, and actually denominator, because we had a negative 7/4 to start off with on the bottom x value, and then we had negative 2 on the upper y value. We are now on part 4, well, video number 3, but part 4, which is radical and rational equations. And we are given the equation negative 5,126 is equal to negative 6 minus 5 times the cube root of 3x plus 22 all to the 5th power. So the first thing I did over here was isolate the radical. So as you can see, the radical was 3x plus 22 to the 5th, and it was attached to that negative 6 and the negative 5. So the first thing I did was add 6 to both sides, and then I got negative 5,132 is equal to negative 5 times that radical, and then I divided both sides by negative 5 to get rid of it, and I got 1026.4 is equal to the cube root of 3x plus 22 to the 5th root. So we have now isolated the radical term. So next, we don't actually, when solving this, we didn't have to use the negative exponent property to change the base, since we didn't have any negatives to deal with. So let's move on to solving for x without a calculator, which can be seen right over here. So I set up the equation as it was, and then I moved quickly to isolate x, which was the main thing we wanted here. Let me zoom in on that. Which was the main thing we wanted here. So let's see what I did. I got rid of the 6, which was the simplest thing to get rid of immediately, and then I also divided out by 5. Or no, not divided by 5, excuse me. I moved this as a 5/3 because we have a 5th power over here, and we have a cube root, so that will just become 3x plus 22 to the 5th over 3 power, and then we eventually get negative 5,132 is equal to negative 5 times 3x plus 22 to the 5th over 5 over 3 root, and then, whoops, that's not seen, was it? And then you multiply the 3/5 to the 5,132 to get rid of the 5 over 3 root over here, and then that gives us negative 5,132 to the 3/5 minus 110 is equal to negative 15x plus 110. Oh, well, that's where we actually got the negative 110 from. We subtracted the 110 from the negative 15x, which was left from that 3x plus 22. And then we were left with negative 5,132 to the 3/5 power minus 110 divided by negative 15 is equal to x. And that's as simple as we can get without using a calculator. Now, there were no extraneous solutions, so that pretty much wraps it up. I hope you have learned something from me working out all these problems. And yeah, this video is going to be coming in 3 parts because of my phone's limited memory usage. Thank you.